Hey everyone, before I throw myself into the most epic, explosive, and absolutely horrifying deaths you can possibly imagine, all in the name of science, of course, please take 2 seconds to hit that like button and smash subscribe. Trust me, you do not want to miss what comes next. Last year, you all loved watching me die heroically on every single planet in the solar system. So this year, the What If team is cranking up the stakes. We're sending me to die even more epically, more explosively, more terrifyingly, in some of the absolute worst places in the entire universe. We're talking supernovas and black holes and entire galactic clusters reaching over 160 million Kelvin. That's a lot of heat. Get ready to see what it's like to die in the most terrifying things in the universe. Starting with something close to home that we all know and love, the sun. You guys asked for it, so here we go. Dying on the surface of the sun would be horrifying beyond belief. Picture this. You're used to seeing the sun from a distance of 150 million kilometers, about 93 million miles. Even from that far away, you can't stare at it for more than a second without those special cardboard eclipse glasses. Now imagine getting as close as human technology has ever been. That's the Parker Solar Probe. In 2024, it dipped into the edge of the sun's corona, just 6.1 million kilometers above the surface. Suddenly, you see the sun for what it really is, a G-type main sequence star, a galactic inferno over 1.4 million kilometers across, filling your entire field of vision with nothing but stellar plasma. Terrifying, right? But we're not stopping there. We're going all the way down. Now, some of you might think you could just zip down to the surface. Let me stop you right there. First off, the sun's corona is way too hot to fly through. It's 2 million degrees Celsius. That's 3.6 million degrees Fahrenheit. Why the corona is hotter than the surface of the sun is one of the great mysteries of the solar system that scientists are still working to unlock. Also, all that radiation and solar wind would fry your ship on the way down. You'd have to slow down your spaceship to the perfect mathematical degree to actually land. Otherwise, you'd be caught in its orbit and never be able to get out. And finally, the sun doesn't actually have a solid surface. The closest thing, the photosphere, is plasma. It'd be like landing on lava soup. So we'll have to teleport you directly to the surface. Now, you might think you'd last 5 seconds. Spoiler alert, you won't. We'll have to do this in slow motion. The surface of the sun isn't as hot as its corona, but it's still 5,500 degrees Celsius. That's 10,000 degrees Fahrenheit. The very instant you teleport to the sun, it's so incredibly bright that you'd be blinded instantly. Actually, it's so bright that we had to ask our video editor to drop the video levels, because otherwise the screen would be pure white. You'd immediately feel the sun's mass, the power of its immense gravity straining at your muscles, at your very skeleton. It's 28 times stronger than Earth's gravity. Your spacesuit would protect you from the sun's rays, but only for a few milliseconds. Within 0.1 milliseconds, your suit would start to char. The plastic would begin to warp and your visor would melt. Then your skin would start to melt. Everything would start to melt. It's hot enough on the surface of the sun to melt diamonds. Actually, it's hot enough to boil diamonds. After half a millisecond, your suit would be compromised, and boiling plasma would hit your body like a shock wave. It would happen so fast that you wouldn't even have a chance to feel it. Your body would cook, suffering complete organ failure before you could even register that there's a problem. Within 10 milliseconds, your flesh, bones, hair, and muscles are turned into gas and plasma, burned through completely. In what would seem like a single flash of light, you're gone. Incinerated. You've become one with the sun. Now that's what I call metal. Get it? Like metal? Iron in my body? Never mind. Speaking of heavy, let's move on to black holes. Is there anything about a black hole that isn't terrifying? Nope. Black holes suck, as in they suck everything in their vicinity into them. That's some astronomical comedy gold for you. Now, the nearest black hole to Earth is called Gaia BH1. It's a stellar mass black hole, roughly 1,500 light-years away. But don't worry, if light were able to escape a black hole, it'd be well into the 36th century before we saw it. Nothing's escaping that monster down there. You might be wondering, is that the huge black hole at the center of the Milky Way galaxy? No, that's Sagittarius A-, a supermassive black hole. But scientists think that there's a supermassive black hole at the center of most galaxies. But that doesn't mean there aren't smaller black holes around. Gaia BH1 is a stellar mass black hole, much smaller than a supermassive one, and it shares its orbit with a star similar to the Sun. These stellar mass black holes are the remnants of massive stars that have burnt through all their hydrogen and helium and imploded. They're living tombstones of giants. Gaia BH1 has a mass about 10 times that of our Sun. And dying in this black hole would be brutal. Let's set the scene. Your ship is approaching the black hole. Warning: ship is approaching accretion disk. What's an accretion disk? It's all the matter and gas swirling around the black hole before it falls in. The real killer here is the black hole itself. Once you cross a certain distance to the black hole center, known as its Schwarzschild radius, you are in serious trouble. The instant you get too close to the event horizon, things get weird. Your body undergoes a process called spaghettification. You would be squeezed horizontally and stretched vertically. Even though you're human, your body turns into a noodle, a piece of spaghetti. Your spine, bones, and skull would be stretched and elongated, cracking and shattering, slowly losing their shape. As you fall, time itself would begin to warp. To an outside observer, you'd appear to slow down, frozen at the edge of the event horizon forever. But from your perspective, time wouldn't stop at all. You'd keep falling, feeling the pull grow stronger and stronger until gravity finally tears you apart. Now that is heavy. Nothing worse than those black hole suckers. But wait, there's something even denser and more dangerous. Let's talk about neutron stars. Specifically, RxJ 185635-3754. The closest neutron star to Earth, roaring at just 200 light-years away, is so heavy that a single teaspoon of that neutron star would weigh 1 billion tons. Even though it's only about 20 kilometers wide, that's just 12 miles. It's one of the densest, most dangerous cosmic bodies in the universe. Almost as dense as somebody else I know. Neutron stars are weird objects, primarily composed of neutrons, hence the name. The pressure here is so intense that atoms are crushed together. Protons merge with electrons, forming neutrons. The surface of a neutron star is just pure neutrons, 10 billion times stronger than steel. If you got too close, the electronics on your ship and even your suit would short out due to the pulverizing strength of its magnetic field. Within milliseconds, X-rays and gamma rays would destroy you at a cellular level before you could even react. Within a tenth of a second, the radiation would boil your skin and blood. And then that gravity, not unlike a black hole, would spaghettify you. Your ship and your body would be stretched to their breaking point, then stretched further and further until every cell and every atom in your body had become miles of silly string, vanishing into the neutron star. Absolutely horrifying. Now, let me introduce you to an even more terrifying cousin of the neutron star, the magnetar. A magnetar is a neutron star with a magnetic field 1,000 times stronger than an ordinary neutron star. We're talking about a magnetic field that's a quadrillion times stronger than Earth's. If you came within 1,000 kilometers of a magnetar, the magnetic field would literally rip the electrons out of your atoms. You wouldn't just die, you'd be unmade at the subatomic level. Your body would become a cloud of ionized particles, and your consciousness would end before you could even blink. And here's the kicker: magnetars can have starquakes. When the crust of a magnetar cracks, it releases a blast of gamma rays so powerful that it can wipe out half the life on a planet from thousands of light-years away. If you were unlucky enough to be near one during a starquake, you'd be vaporized instantly. No soup, no noodle, just pure, silent, instant annihilation. Okay, you might be thinking, can we go somewhere without spaghettification or magnetic shredding? Somewhere fun? Somewhere I don't get turned into linguine? Let's pick somewhere fun, right? Well, the next destination is absolutely petrifying. Billions of light-years from Earth, a place beyond terror, El Gordo. El Gordo. It sounds like a lookador, or the guy who makes sandwiches for a lookador, or the guy who sews up the tights of a retired wrestler who makes sandwiches for a lookador. But trust me, El Gordo is no joke. El Gordo is a cosmic furnace born from the collision of two galaxy clusters. It's one of the hottest environments in the known universe. We're not talking about one galaxy smashing into another. We're talking about thousands of galaxies in the midst of an intergalactic smash-up derby. Imagining the violence is difficult, but dying in El Gordo would be explosive and hot. Imagine you're drifting along in space, riffing about luchadors and sandwiches, and suddenly your ship registers a radiation count that goes through the roof. You're flying into one of the hottest galaxy clusters known to science. Your ship registers a temperature of 160 million Kelvin. Since you can't understand Kelvin, your computer translates it to Celsius and Fahrenheit. But those millions of degrees barely seem real, and you know that things are about to get way too hot. At that point, you cross into El Gordo and hit a local shock front, a cosmic shockwave traveling at thousands of kilometers per second. Your ship would be shattered like the worst car crash in history. You would be thrown clear of your ship into outer space. Your body would be bathed in radiation and struck by hot gas, hotter than the surface of stars. And then the heat, the wall of pure heat strikes. You would start to boil, vaporize, even ionize in an instant. So, lesson learned. Never make fun of anyone or anything named Gordo or anything that sounds like that. Definitely not Kevin. Something feels off, like something looming behind me. But no, it's right in front of me. You just went back in time 3.5 billion years. You're just in time to witness a supernova. This particular supernova is called SN 2016 APS. And it's not just any supernova. It's the brightest and most energetic supernova ever observed. Scientists think it's a rare situation where two massive stars merged before the explosion, making the supernova extra explosive.
Mega boom.
The stars collapse and then explode. At its height, the explosion is 100 billion times brighter than our sun. That's as bright as our entire Milky Way galaxy. If you're hanging out nearby when it goes off, it's not going to be good news for you. Let's break down your death in a supernova. After 1 millisecond, a torrent of neutrinos would flood through your body, heating and rupturing your cells. Neutrinos are ghostly particles that usually pass right through you, but in the heart of a supernova, there are so many that they become deadly. After 5 milliseconds, the shockwave would slam into you at thousands of kilometers per second, shredding your body before your senses and pain receptors can even register what's happening. After 10 milliseconds, you'd be gone. Your atoms carried away in the scorching ball of plasma. So that's what it would be like to die in a supernova, one of the most violent events in the universe. But let's not stop there. There are even stranger and more terrifying places. How about a quasar? At the center of many distant galaxies, supermassive black holes are actively feeding on vast amounts of gas and dust. The energy released by this feeding process turns the black hole into a quasar, the brightest object in the universe. A single quasar can outshine an entire galaxy of hundreds of billions of stars. If you were anywhere near a quasar's relativistic jet, a beam of plasma and radiation shooting out at nearly the speed of light, you would be disintegrated instantly. But even from millions of kilometers away, the heat and radiation would fry you to a crisp. The quasar's accretion disk is so hot that it emits X-rays and gamma rays that would kill you from a distance of several light years. And if you somehow fell into the quasar's accretion disk, you would be crushed, cooked, and torn apart by tidal forces long before you ever reached the black hole itself. It's like the sun's death multiplied by 1 billion. Now let's talk about something completely different, a rogue planet. A rogue planet is a planet that doesn't orbit any star. It wanders alone through the cold darkness of interstellar space. Without a star to warm it, the surface temperature of a rogue planet is just a few degrees above absolute zero, around minus 270 degrees Celsius. That's colder than the surface of Pluto. If you landed on a rogue planet, you would freeze solid in seconds. Your blood would turn to ice crystals, your skin would shatter like glass, and your eyes would freeze in their sockets. But here's the really scary part. Rogue planets are invisible. We can't see them because they don't shine. One could be hurtling toward Earth right now, and we might not know it until it was too late. And if you were on a spaceship that crashed onto a rogue planet, you'd have no hope of rescue. You'd be trapped in eternal darkness, freezing to death alone, with no star to ever rise again. Let's stay in our solar system for a moment. You think you know Jupiter? It's a gas giant, mostly hydrogen and helium. But the deeper you go, the more deadly it becomes. At a depth of about 1,000 kilometers below the cloud tops, the pressure is so high that hydrogen turns into a liquid metallic hydrogen. The temperature is several thousand degrees. If you could somehow descend through Jupiter's atmosphere, you'd be crushed by the pressure long before you reached the metallic layer. Your spaceship would implode like a tin can. Your body would be compressed into a tiny ball of dense matter, smaller than a marble. And then you'd keep falling deeper and deeper until the pressure turned your atoms into exotic forms of matter that don't exist anywhere else. Jupiter's core is believed to be a dense ball of rock and ice, surrounded by metallic hydrogen. The pressure at the core is 40 million times Earth's atmospheric pressure, and the temperature is 20,000 degrees Celsius, twice as hot as the surface of the sun. You wouldn't just die, you would be destroyed on a molecular level. Now, let me take you to a place that isn't even a planet or a star. It's called a dark matter anomaly. We don't know much about dark matter, except that it makes up 85% of all matter in the universe, and we can't see it. But sometimes, dark matter can clump together into dark stars or dense clouds. If you flew your spaceship into a dark matter cloud, you wouldn't see anything, but you would feel it. Dark matter particles rarely interact with normal matter, but at high enough densities, they could cause your body to heat up from the inside. Your cells would start to cook without any external fire. Your DNA would unravel. And because dark matter doesn't interact with light, you wouldn't be able to see the danger. You'd just suddenly start dying, with no visible cause, no warning. That's the stuff of nightmares. So that's what it would be like to die in some of the most terrifying places in the universe. The sun, a black hole, a neutron star, a magnetar, a galaxy cluster, a supernova, a quasar, a rogue planet, the depths of Jupiter, and a dark matter cloud. Each one offers a unique, brutal, and fascinating death. And that's the beauty of What If. We can explore these horrors safely from the comfort of our own planet. We can ask the big questions without actually putting ourselves in danger. But it's also a reminder of how fragile we are, how tiny and vulnerable we are in the face of the cosmos. The universe doesn't care about our ambitions, our dreams, or our fears. It just is. And it is beautiful, but it is also deadly. If you enjoyed this epic journey through cosmic death, please hit that like button, subscribe to the channel, and turn on notifications so you never miss another mind-blowing scenario. And let us know in the comments. Where should we send our brave explorer next? A white dwarf? A cosmic string? A wormhole? Or maybe into the heart of a star about to go supernova? Until next time, stay curious, and remember the universe is full of wonders, but don't get too close. See you in the next What If.